Hello, my name is William Burnett, and today I want to take you through just a small tutorial on using Desmos in your calculus classroom. I like to use this to introduce e to the x and the properties of e to the x, but you can also use what I'm going to show you with other functions and basically quickly change the function we have graphed here, and a little bit of changes to our formula. We can do the same thing with other functions as well. So basically, this is going to be our end product here. And we're going to have a slider over on the left, and as we change this, we can see the area under the curve change. We can also see our derivative of the function and its value at some a value for x. We can see the value of the function at a, and we can also see the integral there at the f of a as well, and the evaluation of that. So one of the things I like to point out to my students is for e to the x, all three of these are the same. And so this is kind of a cool thing to actually have your students do in class, come up with the codes for this, and then have a little fun playing around with it, see what they can create on their own. So that's what we're going to do. The first thing we want to do here is to log into Desmos. So that way when you finish this, you can title your graph and save it for future classroom use. So go ahead and go to Desmos and log in. While you're getting logged in, I want to point out that this video was supported by the Secondary Mathematics Professional Development Center at Radford University with funding from the Virginia Department of Education through the Math and Science Partnership Grant Program. So basically that's, where this is all supported from, and so a big thank you out to those people that helped make this video possible, and hopefully it's a big help to you. So the first thing I want to do is I want to title this graph. You can title it whatever you want. You can, let's see here, exponential function if you want. And then that way when we hit save up here, we know it's going to be saved into our list of functions that we've done before. Okay, so with that, first thing I'm going to do is graph e to the x. The nice thing about Desmos is it knows when you type in e that you're talking about 2.7182 and so forth there. But I'm going to type this in as e to the x. And I also like to use functional notation so we can use f of x later on here. So I'm going to type in f of x is equal to e to the x. You can make this whatever color you want. I like, I don't know, blue. And so one of the first things I want to do is just evaluate the function f of x at a particular value. So I might make that value a. So let's have the f of a here. Notice a slider appears. I can add that slider, and it will tell me the value of this function at f of a right here. It's 2.71 when a is equal to 1. If I move the slider over, I can see that value change. And so when students are learning the derivative of e to the x, they learn that the derivative of e to the x, or f prime, is going to be the same thing, e to the x. So I want to show that. So if we can actually just type in the f prime of a, and that will tell me the actual derivative of the function at a. And so it's one thing you point out, since they're both e to the x, they're going to come out to be both the same number there. If we had this function something else, like x squared, now I can slide this around and see the different values for when x is equal to 2 there, or a is equal to 2 in this. And notice they're not always the same, and those are things you can point out to your students. Now, I think it's helpful as we drag a to actually see a point move along the graph here. Let's change it back to e to the x. So I'm going to want it to plot the point a comma f of a. And you can add a label if you want to. Here I'm just going to, you can actually title it something like point we're talking about. But I like having the actual values in there. So now I can see at 1.5 our y value is 4.482. And so as we drag this up and down, we can see where that point is that we're evaluating the function at. So if I want to take the definite integral, well, I'm just going to type in the word integral, and as I do that, notice it sets this up for me so I can put an upper bound and a lower limit to it. I really don't have a way to type in negative infinity, so I'm just going to type in a really small number like negative 900, and I'm going to make it evaluate it all the way up to a, and this is just going to be f of x here. And if you want to evaluate it and spit out a number like we have on these other two, you have to include the dx. And notice it gives me a value there from going up to a right here. And so as I slide this, all three of the numbers change, but they're all the same on this one. Once again, if we changed our function, it would be different. So if we changed it to x squared, notice the three values don't stay the same. So another thing that you can point out to your students, and it's an easy thing to do because we can just change whatever we're defining f of x to be. So the other thing I like, once again, is a nice visual, and I want to shade the area under the curve here at whatever a value or x value I'm talking about. So in order to shade it, I'm just going to put in an inequality. And let's set this up as y is greater than 0. Actually, I'm just going to make it greater than or equal to 0. So if you go down to where your keypad is, you have the greater than or equal to. 0. Now notice what that does is it shades everything above y is greater than or equal to 0. That's not exactly what I want. I want it greater than or equal to 0, but less than my function. So let's actually change this around so it's set up like this. Greater than or equal to 0, but less than or equal to my function. In this case, I'm going to take the f of x. And notice now everything in between those two, 0, y equals 0, and y equals f of x is shaded. So I still want to limit this, though, to whatever my a value is, and so I need to put a restriction on my x values. So in order to do that, you've got to do like this squiggly bracket, and we're going to say x is less than a. And so now, as I drag these, where's my slider? It's right here. As I drag that slider, it's going to shade just in that area. So it gives a nice visual representation of the area under the curve. Now, I still don't like, this is just for looks, nothing really else beyond that, how I've got a bold line here and a bold line here. By the way, if you just did less than the f of x, you wouldn't have that bold line. It puts in a dashed line automatically. So if I type in less than, you see how it's like a dashed bold line here. So I do less than or equal to just so that you get that nice solid line look to it. But I want a solid line right here vertically. So this is just a kind of, for looks only. I'm going to type in x equals a, and that gives me a solid line right there. And as I drag my a, notice that line follows it. But once again, it's overshooting it quite a bit on both ends here. I want it to be just between 0 and the function. So I need to tell it to restrict my y's. So once again, I'm going to do squiggly bar. And I want it to be bigger than 0. So that's going to restrict my y there. But I want it to be less than the f of x. And I can close my bracket. And now as I look at this, if I move my a up and down, notice how that bar stays with it. But I don't think it looks too nice being green. I'm going to change that to blue just by holding down on this. That's just left clicking it and then selecting blue. And now it looks like it's all one piece here, even though it's several different pieces of code here put together. And we can change things around. If we change the function, say back to x squared, see how everything else changes here. You might want to change your bounds here. You might want to change this to 0 in class, and then you can change let's see here, the shading to 0 also, so that it's x is less than a, but it's bigger than 0. And now as I drag this back and forth, you can see, you get just a different visual for that function there. So that's what's nice about this. After you set it up and save this, you can change it around and save the graphs as different things in here as well. So this takes us back. I just Control Z till we got back to where we were before. And so now we have this function as it is. There's some other things we can do though that I didn't show you in the intro. We can also add the graph of the tangent line. So if you want to let your students see what the tangent line looks like at different x values, you can do that as well. Now the way I always kind of set this up is I just kind of think of the equation of a line in point slope form. So I'm just going to go y minus y is equal to my slope times x minus x. And now I'm just going to go through and replace a few things. I know that the slope here is going to be f prime of a. Let's change it to the actual apostrophe and a. There's my slope. And then I need one other point besides x, y. And so I'm going to choose at a comma f of a. And so now I'm going to get a line, and notice it's all based off of a, because that's where my slider is. So this slider is controlling all these different things. As I change a, we can see that slope change, and the graph of the line changes there with it. So most times students think that's pretty cool. If we change the function back to something else, let's do x cubed this time just to get something different. You can see the tangent line, and as it moves around x cubed as well. Let's go back to e to the x. There we have it. Maybe you don't like that. Maybe you just want to show it for a moment. You could already have this pre-programmed in as you're teaching. You can remember, you can turn off any of these things that we put up here just by clicking on it. It still stays right here. The only way to delete it is just to exit out or highlight it and delete it. But this just temporarily hides it, so you can kind of make it a nice clean presentation and then bring up certain points when you want to. Now, while we have e to the x graphed here, one other thing I like to do with my students is to kind of just reinforce the idea of e to the x and the natural log of x being inverses to one another. So in order to do that, I like to graph the natural log of x with e to the x here. To do this, I'm going to first kind of clean this up, and I'm going to hide these other parts. And just take it all the way back down to e to the x. Actually, I might leave that point up here. And everything else is turned off. Let's go ahead and graph the natural log of x. And I'm going to let this be the g of x. And so you can say, hey, we can see how these are reflected over the line y equals x. Let's go ahead and graph y equals x. So y equals x, and you can, once again, you can change this to just be a dashed line if you want to. Left click on the circle right here and you have different options. You can make it a dashed line, you can make it a dotted line, you can change the color. I'm going to make it a dashed line just because that's typically how I draw it over in my class, so we can see the reflection there. And then one other thing I like to do is add another point that's being traced out on one of these graphs on the natural log of x here, just to show that as I drag a back and forth, these inputs and outputs are reversed because we're talking about inverse. One is the inverse of the other. So to drag a line along the natural log of x, all I'm going to do is tell it to graph the point f of a, which is the output here on the e to the x, comma a. And so let's go ahead and label it so we see the input and output up on the screen. Let's see if we can make that output black so it matches the function. We can even come up here and make this one blue if we want to. Where's our point we had? Right here. That way it matches e to the x there. Keep in mind you have other options here. If you want to not make it a solid dot, if you want to make it like a little circle like that, you can. If you want to make it an X, you can. All depending on what you're doing. You may or may not like that. So now we see as we drag back and forth A, both points drag on each function. And I can see right here if I put in e to the x or make it e to the 0.9, the output is 2.46. If I take the natural log of 2.46, the output is 0.9. And so using Desmos, we've got two different ways of showing that these two functions are inverses of one another. Now, we've got a lot of code over here on the left, and I guarantee you, if you've typed all this out, and about a year from now, you won't remember what any of this went through. I mean, you could look at the code and figure it out, but I like to have it a little bit better organized than that. So that's where folders come into play. So let's see if we can add a folder. And you can label this anything you want. So let's label some things in here. Now, I'd like to keep my function visible. So e to the x, I don't want that really being tucked away in a folder. And I like these outputs here, especially for e to the x, just to evaluate the function at those different things. And I also want to keep my slider. Now, I may want to move some things around, like move f prime right here next to the f of a. And I might want to move this integral up, so that way I get all three of these shown right here. You might like the slider at the very top, right below the function, so you can see as I change this, all these values change. And the only thing I would recommend for Desmos, and hopefully they'll do this in the future, is allow me a spot where I can label and say the derivative or f prime of a equals and have that nice on display. Unfortunately, if you're displaying this in your class up on the board, it's kind of hard to see. You've got display mode over here underneath the tools. You can click on projector mode and it just kind of bolds everything, but it doesn't really make this any larger for the students to see. So if you got one-to-one devices, it's great. The kids can see it right there at their desktop, but otherwise when you're trying to display it, you've got to kind of read it out to them or have them move closer to the board. Now these points though, see this is our point a comma f of a. This isn't really necessary for me to have on the left. In fact, I don't really touch this after I put it out there, unless I'm saying, hey, I want that turned off. So I'm going to tuck this away in a folder. So let's move it up to that folder. And you can just drag and should be able to just drop it right into that folder. And it's a little bit tricky, but notice as I get ready to drag it right to the folder, there's a line that appears right here. And once I get to that spot, I know I'm like inside of that folder. So I'm just going to let it go of it right there and see how this is lined up. That is now inside that folder. I'm also going to take the other point we have, which is right here, and I'm going to drag that into that folder as well. So that's now nested into that folder also. So if I click on this arrow right here, it kind of closes the folder, so I don't have to look at all of it. But we also want to label that folder. So let's label it, I don't know, labeled points. And so let's make sure they're both turned on. You could turn them off individually inside the folder. Let's drag our A down so we can see it. There they are. So I can turn them off individually. Looks like we might have to turn off the label also if we want them to completely go away. Individually, one by one. But if I wanted to turn them all off at once, I could just click on the folder now, and it turns everything inside that folder off. So that's kind of convenient too if you wanted to turn on or turn off a group of things. We'll group those things, put them in a folder, and then you can turn on and off that folder as you go there. So I'm going to close that down. Here's our labeled points. So let's look through this list and see what else that we can put together in a folder. I don't like all this. This looks very messy. This is our inequalities we've got going on. So let's make a folder for that and put those together. So I'm going to add a folder, and let's just call this shady stuff. Remember when we had those turned on, it's where our shaded parts were for the area under the curve, and as we dragged A, it moved up and down. So I'm going to take that shady stuff and put it into the shady stuff folder. So we line it up right there. There's our other one right here. It is. They're usually pretty easy to pick out when you're looking at somebody else's work because that's where all of our inequalities are. So I can close that folder if I want to. If I don't want to see all that shady stuff, I can just click on the folder and it turns it off. Turn it back on and I can throw some shade on the graph. Next, because I am planning on this lesson to be something where I'm talking about e to the x and these three numbers being the same, I'm not going to start off by talking about natural log or y equals x or anything to do with the inverse of it. So I might add a folder that says inverse discussion. And keep in mind, I'm not only planning this for maybe a lesson I'm doing next week, but maybe a lesson I'm going to do every year. And so a year from now, I may not remember why on earth did I have this code down here. I mean, I would once I start to graph it, but just to kind of keep things organized, I like doing it like that. So inverse discussion, I think when I open up this, I'll remember like, oh yeah, that was my, when I was talking about the inverse, I can open up that folder and turn on that folder or turn it off as I need to. So now I can close that up. If I don't want to see it on my graph right now, I just click on the folder and it turns all of that mess off. And now I can go back to what I originally talked about. Oh, look, that point's still there. So I might want to turn off that labeled point individually. And the label, because I don't want that at the beginning. So maybe that's not the best way to organize that. You do, what you want to do with that. If you want to put a note on here, let's say you are planning on using this every year. At the end of the lesson, some student brought up a good point or a good question, a good discussion topic you want to talk about in the future. Remember, you can add an item and you can add a note. And you can say, remember to discuss whatever with the students. And you can, tuck that away in a folder so students don't see this if you're projecting it, or you could put it down at the bottom of this list so that you just have all your notes on these things set up there. Either way, when you're done with all this, make sure that you click on Save here. So that way it is saved over in your 3-bar in the top left. You can pull up this in the future. Now, if you wanted to change this, you've done a lot of work here for shading and finding the derivative and the definite integral and all that. Let's suppose you wanted to change this function and save it again. So let's change it to the sine of x. So there's the sine of x, and you can change this so it's not showing up as 0 and 2 and 4. We discussed this in one of the other videos, but real quickly you can change it to go from 0 to 2 pi if you want to on the x-axis. So I would just change your step to pi, and it kind of does that already. It's already in radians for me here. And you go from 0 to 2 pi. You can see that a little bit better. And as we look at this, there might be a few things you want to change here. As I drag this along, you can kind of see, maybe I don't want it to shade all of these. I might want to just shade from 0 to pi. So you got to go back. Where's our inequalities? Here's our shady stuff right here. And so I want to go from 0 to pi, and you can restrict your domain to that if you want to. Let's see, x equals a, that's not what I want. 0 less than x is less than a. Let's try, let's see here, but greater than 0. Oops, had that backwards. And so now that's going to restrict it, but less than a. So this will at least restrict it to where it's positive as you go through there if you want to. You could do 0 to pi if you want, just by saying don't let a be bigger than pi if you want to. So you can go back up to where or go down to where your a is and restrict this between 0 and pi. You could have done it that way also. And now as I drag this back and forth, it only goes between those 2 points. A lot of different things you can do with that. Let's look at our tangent line. Let's turn that back on. And as we drag it, that looks like it still works. I don't have to do any changing to that. All different discussions you can have here with different graphs, and notice once you get a little comfortable with it, you can switch back and forth and change these things as you want. That's why I think it is important to kind of label things, because that way if you are changing things on the fly, if you think of an example right in front of class and you want to just try out something different, you can see exactly the stuff that you've typed in before, even if it was a year ago that you typed it in. But because we did all this work, we now have a new graph here, and we can save this as something else if we want to. So notice if we go over here, it says duplicate or rename. So if I click on this, I can change this to the sine function, or however you want to put it, sine graph. Capitalize that. It says duplicate this graph and hit save. And now when I go to my list here, I've got the exponential function that I last saved 3 minutes ago, the sine graph right here that I saved less than a minute ago, so I can go back to that sine one, not sine one, e to the x one, and there it is, and everything's saved like it was. Or I can go switch back to the sine one now. So you can set up a whole bunch of different graphs and build on your previous graphs. Just make sure that when I click on this, that you click duplicate the graph. If I just said, you know what, sine graph is an awful name, I just want to change the name of it to sine curve or something. Don't click on duplicate, so check off that box, hit save, and all it did was rename it now. So now when I look at it, it's sine curve. But just be careful. Make sure that if you're just wanting to use a previous graph and change it around and save it, that you do click on duplicate so it doesn't save over. It's kind of like the difference between save and save as. You know, if you click on duplicate, that's like saying save as in another program. If you click off duplicate, it's like saying save, so you're changing the name of it there. All right. So hopefully this gives you a good base to start with. Things I would recommend is to try this out yourself. Come up with an idea and try it out yourself. This idea that I got for e to the x came from a friend of mine, Bill Eggle. He teaches here with me at Jefferson Forest High. He does the calculus class. I teach pre-calc. But we were discussing e to the x, and this was an idea that he had. He shared with me. I thought it was pretty cool. But, you know, he showed me how to do it. But at the same time, I just kind of said, okay. And then I waited a few days and went back and tried it out myself. Because as you try these things out, you have to think about a lot of math and how to code it and how to shade it and make it do what you want to do. I think it's a great thing to share with your students as far as an assignment. Go home and graph this function and show the area under the curve, because they're going to have to start thinking about inequalities. They're going to have to start thinking about organizing their thoughts. And really, I think it sets them up for computer programming, giving this machine a set of instructions to graph something you want it to graph, specifically how you want to set up so that you can drag a slider and show the tangent line. They need to know the math, and they have to think about the instructions they're giving a computer, which is, you know, good for, you know, other things like computer programming. So I think it's a great assignment to give them. I think it's a great challenge to us as teachers as well to try out. And so hopefully this video is a help to you, and it will encourage you to try new things and come up with new ideas that maybe you can share with me. Thanks for watching, and once again, I hope this was a help.